Hello everyone, and also hello to my dear panel. Today I'll be presenting about Bachelor Degree Project 1 title, which is Counter Error Analysis on XY Milling Table via Implementation of Super Twisting Sliding Mode Controller. My name is Pravinan and my metric number is B051710096. Before we start, I would like to let our panel know that this title is a continuous of previous PSM students title because it is still under analysis progress. So let's look into introduction first. Contour analysis of a position table via robust controller under influence of input cutting force. The project is about the development, validation, and analysis of precision control of a milling machine's XY positioning table exposed to the input disturbance force such as friction effect and also chattering. A robust controller called super twisting sliding mode is the precision control algorithm selected to this project. This project is an extension of a previous final year project using MATLAB or Simulink software to design and numerically evaluate the controller. Now let's look into the background of this project. Computer numerical control CNC machines are most commonly found as the tool for manufacturing metal based on the product. The main machines mostly used in manufacturing industry is milling. CNC machines are known for their ability to produce parts and products in an effective manner and efficiently. There are several techniques of material removal for milling processed materials such as perform isolated and cutting. Unfortunately, this complex motion control system used when output tracking signals present a bit of motion of limited recurrence as well known to detect tracking performance. In milling machine process, two factors that most often reduce tracking performance are chattering and friction effect. So, to minimize the error tracking efficiently in machine tool, a robust position controller design was built and is known in literature as super twisting sliding mode controller. This mode of controller is able to balance the system states at the limited time in order to less the chattering. Super twisting sliding mode controller is just not robust to different disturbances and vulnerabilities, but it can also alter the track system exactly. So now let's look into the problem statement. The main issue associated with applications of automatic control system it is ability to compensate for external disturbance while safeguarding precision and accuracy of the system. The disturbance can be in the form of cutting force and also friction force. Various methods and approaches have been developed over the years in addressing this issue such as sliding mode controller. Sliding mode controller suffers from vibration effect known as chattering as a result of the discontinuous function in its algorithm. In precision situation during machining happening, the vibration amplitude happen increased constantly until the elimination between the cutting tool and workpiece is extensive perfectly to the point that the tool will leave the workpiece for a few times. The friction can happen when some parts in machine make an uncountable hit. When movement of tools move faster, more friction can cause defect to the workpiece. A robust controller with friction compensation and disturbance rejection capability can be used to control the positioning of XY milling table. The application of such controller in a manufacturing setup thus help in managing the tracking error, counter error, friction compensation and disturbance rejection ability of the system, producing highly precise parts and components. So now there are three objectives for this project. The first one will be to apply a robust position controller for precise positioning of a manufacturing system. The second objective will be to analyze the precision of the positioning control system in terms of tracking error. And the last objective will be to evaluate the robust controller performances in terms of disturbance rejection. There are also four scopes for this project. The scopes of these projects are only limited to XY milling positioning table. Analysis limited to contour and axial tracking errors. Stimulation by using MATLAB or Simulink software only. Input signal in the form of sinusoidal signals, measured cutting force and white noise. So now let's look into the literature review of this project. So number one is the milling machine. The milling machine is the most used in workshop, university and many company manufacturers now. In theory, when position drill press to drill something, it is very useful to do machining job like cutting or drilling rather than lathe machine. This figure shows the position of XY table milling machine. Now let's look at the one of the parameter of this project, which is feed rate. According to H.P. Shaputra, H.M. Yang and B.M. Chang and T.J. Ko, they are designed dual-stage controller which is about a positioning system with long stroke and high precision. This control method was used in system dynamic compensation type, where the error from linear stages becomes the input to the physioelectric actuators. Using dual stage control, the stroke can be decreased from 30 micrometer of positioning error with single stage control in a 1 millimeter stroke to 2 micrometer. Next, let's look into cutting force issues. Cutting force is a force that uses cutting tool on the workpiece which is produced by the machines. However, the cutting force have a several issue which is leading to vibration, friction, counter error and tracking error. According to R. Ramesh and M. A. Manan and A. N. Poom, there are several factors that have complex interactions includes basic of design machines that have competence and equivalent on the X-axis servo system. In the servo system control, there are two factors that can be impact to machine which are tracking and counter error. These two factors can give a defect to workpiece and performance in the end of cutting operation. Now, the last part of our literature review will be super twisting sliding mode controller. According to Liusef, D. Pere, Moreno and Jungas, sliding mode controller SMC have two steps of design which are design of sliding manifold and design of high frequency. Then design of high frequency is changing control law which can be applied or set the trajectory to the sliding mode. These two equations are used to design the manifold and the high frequency. As you can see on equation 2.1 is the design of sliding manifold, while equation 2.2 is the design of high frequency. The methodology of this project is implementation is summarized by the flow chart that describes the overall planning and stages involved for successful completion of this project. There are several methodology to complete this project successfully. This is the flowchart on how the project will be started and until the ending all the process of this project. First we'll start from background of research project and then literature review and apply control scheme on MATLAB or Simulink. Link control scheme with hardware via DSpace 1104 control desk. Run the experiment on the x-axis of the XY positioning table. Tracking experiment on the test setup. If it's failed, we go back to the apply control scheme on MATLAB or Simulink step. If yes, then we continue to measure data analyze for position accuracy or disturbance rejection, and then we go to the conclusion and we complete the report and our project is completed. This is the control desk which is used in this project. This control desk is the DSpace experiment software for seamless ECU development. It performs all the necessary tasks and gives you a single working environment from the start of experimentation right to the end. So as we can see, there are four components used, which is a personal computer with MATLAB and control desk software, and digital signal processor DS1104, and the amplifier to the plant. So once we successfully set up our all the components, these are the data analysis I will be gathering in this project. So first we'll be gathering data for tracking performance only without input disturbance in x-axis, and then we will be getting data analysis for tracking performance only without input disturbance on y-axis. After that, we'll be getting data analysis for tracking performance only, without input disturbance on both x and y axis. And the last part will be getting data analysis for tracking performance with input disturbance and in both axis, x and y axis. In third and fourth, we will be perform circular tracking as we include both the x and y axis simultaneously. Thank you. I would like to use this opportunity to wish my panels a happy new year. Thank you.